This example on heat says, a helium gas of very low boiling point as well as low latent heat of vaporization, which is equal to the value 2.09 times 10 to the power 4 joules per kilogram. If energy is transferred to a container of liquid helium at the boiling point from an immense electric heater at a rate of 15 watts, how long does it take to boil away 3.0 kilogram of the liquid? So, looking at this example, we are being given the latent heat of vaporization to be 2.09 times 10 to the power 4 joules per kilogram, and the power rating is given as well, which is 15 watts. The question now is, how long does it take to boil away 3.00 kilogram of the liquid? In this case, how long is referring to time. So we have to estimate the time, and then the mass of liquid which is going to be boiled away is 3.00 kilogram. Okay, let's go down and then look for a suitable expression which we are going to use. But before that, we have to highlight or put down the quantities, and from there we are going to decide on the expression we are going to use. In this case, we have the latent heat of vaporization to be given, the power rating of the heater is given, the mass which is going to be boiled away is given as well, and we are to find the time. Okay, all right, so what we are going to do next is to decide on the expression which we are going to use. So equation 1 will help us to find the quantity of heat Q if we multiply the product of the mass and the latent heat of vaporization. But that is not all. We still have other expressions, but in this case we will call this the energy required to vaporize 3.0 kilogram of helium. So Q is the energy which will enable us to boil away 3 kilogram of helium. We also know that Q equals to PT. This is the second expression. Q equals to PT. Okay, so when we are able to estimate the quantity from equation 1, we can as well substitute that value into equation 2. We already have P, which is given as 15. We can as well substitute that into 15, into P, and then we make T the subject. We can as well equate both expressions, equation 1 and 2, together this way. Equating both expressions, equation 1 and 2 together, then we will have PT equals to MLV. PT equal to MLV. So all we need to do is to make T the subject, or we go ahead and substitute the values and then we solve for T. So if we do that, then we will have 15 times T. Remember, 15 is the power rating. So 15 times T equals to the mass, which is 3.0, times the latent heat of vaporization. So of course, at this point, we are going to divide both sides by the coefficient of T here, which is 15. Okay, so this is how the expression would look like. We multiply the numerator 3.0 times 2.09 times 10 to the power 4, and we'll have a new expression. Okay, so when we divide this by 15, then we get the time in seconds, which is 4180 seconds. Okay, so thank you very much for watching this example. I would like you to subscribe to our channel if you have not done that. Also refer the channel to your friends. Have a wonderful day. Bye.